Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at the graph of a rational function, and then we're going to go ahead and build that function based off of its characteristics, such as x and y intercepts, vertical and horizontal asymptotes, holes, and other parts of this. So let's go ahead and get started. There's a lot of different places we can start, but first thing I'm going to do is I'm going to write y is equal to, and we don't know if there's a constant multiple, so I'm going to put a little a out front here, and then I am going to put a quotient line, and we're going to find the factors that we think are going to be on the top and the factors that we think are going to be on the bottom, and then we're going to solve for the a finally. So remember, the factors on the bottom appear as either vertical asymptotes or holes. Vertical asymptotes or holes. So here, let's start with the vertical asymptotes. It looks like we have a vertical asymptote here at 1. So that would suggest that we have the factor of x minus 1 to represent that vertical asymptote. Looks like we also have a vertical asymptote here at x equals 6. So that one is going to be represented by x minus 6 as its factor. And that's all for vertical asymptotes. But remember, we also have to look at holes. And we see there's a hole right here at the x value of -2. So that's going to correspond to an x plus 2 factor on the bottom. So now that we've got all the vertical asymptotes and the holes converted into factors and put on the bottom of our rational function, now we're going to take a look at the x-intercepts for the top. Well, now before I do anything else, I need to know how vertical asymptotes and holes work. So a vertical asymptote is going to be associated with a factor on the bottom that cannot be canceled with the same factor on the top. But a hole is a factor on the bottom that can be eliminated with a factor on the top. So since our hole is represented by the factor x plus 2, that means that I need an x plus 2 factor up on the top in order to cancel out on the bottom, so I get that hole at x is equal to -2. So that would be my first factor, and I know that only because of how vertical asymptotes and holes work. The next thing I'm going to do is I'm going to look at the x-intercepts. So we have one here at x equals -1, so that's going to be represented by the factor x plus 1. And it looks like we also have one here at +3, which will be represented by x minus 3. All right, so the actual factors for the top and the bottom were not too difficult to find. And now let's take a look at the multiplicities. So remember, for the vertical asymptotes, if we're approaching a positive infinity from one side and a negative infinity from the other, doesn't matter which sides, but if they're approaching opposite infinities, that means we have an odd multiplicity. And that means that, for example, right here, where we have a vertical asymptote through x is equal to -1, from the left side it's approaching negative infinity, and from the right side it's approaching positive infinity. Again, that's odd, so I'm going to start with a little 1 in the exponent position. All right, now let's take a look at the one that happens at 6. Again, one side is approaching a negative infinity and one side is approaching a positive infinity, so that will also be an odd multiplicity. And for x plus 2, which corresponds with the whole, we really don't know yet, because multiplicity for the bottom is tied to which directions the function is going as it approaches that x value. And for the top, the multiplicity is derived from whether or not it just touches the graph at the x-intercept or it crosses through. So here, I'm just going to leave this as a 1 as well. And on top here, I'll just leave that as a 1. Now this may end up having to go up depending on some other factors. All right, now let's look at where it crosses at -1. It looks like it fully crosses through the x-axis. So that will also be an odd multiplicity. So I'll put a 1 there. And at x equals 3, again, crosses through. So that's also odd. So it looks like we pretty much have all odd multiplicities. For the bottom factors, it would be even if they were both approaching positive infinity or if they were both approaching negative infinity. So if they're both approaching the same infinity, then that would be an even exponent. And if they're both approaching odd, it would, or excuse me, opposite, then it would be an odd multiplicity. And then for the top factors, if it crosses through the x-axis there, that would be odd. And if it were to just come touch it and then go back in the other direction, then that would be even. So we've got a lot of odd. So we've got almost our entire function built. The only thing we really need to know is what is this a value? And in this case, we can go ahead and use this little y to solve, the y-intercept. One other thing I also want to mention as well is we have a horizontal asymptote as it looks like at y is equal to 3. So we can also use that y is equal to 3 to find the value of a as well. I'm going to use the y-intercept, which is a little bit harder, but I think it's more useful in certain situations. So let's go ahead and take a look at this. That's -1.5 or -3/2. Let's say I didn't know that was -3/2. I can just go to my calculator and do -1.5, hit enter, and then hit a math, and then enter for fraction, and it'll convert that to -3/2. So what I can do is I can put a 0 in for x, because notice at the y-intercept, the x value is equal to 0. So I'm going to put a 0 in there. So let's kind of reset this up a little bit. So y is equal to a times, and I'm going to put a 0 in for x. So that's going to be a 2 times a 1, which is 2, times a -3, which is -6. So this is going to be a times -6. And then all over. And now I'm going to put in a 0 for x on the bottom. That's going to be a -1. 0 here is a -6. -1 times -6 is +6. And +6 times 2 is +12. So I'm going to have a +12 here on the bottom. All right, this is going to reduce down to -a over 2, right? -a over 2. Now, when x is equal to 0, so I'm going to put the -a over 2, our y value is equal to -3/2, -3/2. So I now get to solve this equation here. It looks like I can multiply both sides by 2, and that'll cancel out, and I'll get -a is equal to -3. And then if I divide or multiply both sides by a -1, I'll finally get a is equal to 3. So my final function here will be y is equal to 3 times x plus 2 times x plus 1 times x minus 3, and this is all going to be over x minus 1 times x minus 6 times x plus 2. X plus 2. All right. Now we just need to check this in our calculator. But before we do that, I want to go up and I want to look back at this this horizontal asymptote here at y is equal to 3. So remember, the only way that we have a horizontal asymptote that is not y equals 0, so anything other than y equals 0, means that the top and the bottom exponents of the highest terms need to be the same. So if we were to multiply all of this out on the top here, x plus 2 times x plus 1 times x minus 3, we'd get a very large third degree polynomial, right? But the highest, or the first term, which is going to have the highest exponent, is just going to be x times x times x, which is x cubed. Now, on the bottom here, the same thing. X times x times x is x cubed. So if, for example, this a was a 1, we just have x cubed over x cubed. And if I did that, x cubed over x cubed, that's just going to simplify down to 1. So that would mean I'd have a horizontal asymptote at y is equal to 1, which I do not. I have 1 at 3. So if I notice this, and it was an easy enough problem like this is, I could just say, oh, well, I need a 3 up here in order to get that to reduce down to 3, right? 3 over 1 is 3. So I could have done it that way as well, but it's not always going to work. Using the y-intercept will always get you the correct answer if you do it correctly. So again, let us go ahead and get to our calculator. Let's see here. And I'll start to put this in. So go to my y equals, clear these out. And on the top, remember, I want to put the entire top in its own set of parentheses. So 3 times x plus 2, x plus 2, times x plus 1, x plus 1, and then times, and that last one there is x minus 3, x minus 3. Okay, and then remember, close off the entire numerator here, and then divided by, and we're going to need its own set of parentheses for the bottom. So the open parentheses, now another open parentheses to start that, x minus 1 times x minus 6, x minus 6 times x plus 2, x plus 2. All right, close that off, hit enter. Now before I graph it, I want to adjust my window to this one. So it looks like the x values are going to go from -10 to +20. So x min should be a -10. X max should be a +20 because I'm trying to match it up with this one. And then it looks like my y's go from -10 to +10. Looks like I had a window from another problem in here that I never changed back to +10. All right, now let's go ahead and hit graph. And we should get the same graph as we got here, which it looks like we definitely do. So this would be verification that we got it. And that's it for this problem. If you have any questions at all, please let me know, and I hope you have a great rest of your day. Thank you.